Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you like my videos because they are interesting and important to your studies, also please don't forget to subscribe. So here is series of problems on cables. Level 31 problem: in setting its anchor in 100 feet of water, a small powerboat reverses its propeller, which gives a reverse thrust of 800 pounds. A total of 400 feet of anchor chain weighs 1.63 pound per foot, and the upward force due to water buoyancy is 0.21 pounds per foot. So calculate the length L of chain in contact with the bottom. So here is the given figure. So remember, a total 400 feet of anchor chain. This is 400 feet, so the length of the cable from this point where it loses contact with the floor or seabed to this bow of the uh, small powerboat is 400 minus L. And since it's the lowest point on the cable, so the origin would be here, and we will call that distance to this lowest point, of course, as C. So for the analysis, the horizontal component of tension, which is 800 pounds here, is equated to W times C, where W, the net W, the cable is treated as catenary because uh, it is just the weight of the cable that is given and the buoyant force, which is uniform. So the net weight of this cable is net uniform weight is 1.63 minus 0.21, and using the formula tension equals W times Y, or H equals W times C, we can solve for C. And of course, Y at the bow is C plus 100, so we can also compute the horizontal distance from this point to this bow here, horizontal projection. And knowing that distance, then we can solve for L. And take note also that the length of the cable can also be computed as 400 minus L. So everything will be clear after we solve for C. So H is P, 800 equals W times C. The net W is 1.63 minus 0.21. So the uniform weight that is net is 1.42 pounds per foot. So substitute 800 equals 1.42 times C. So C is 563.38 feet. And since Y equals C cosine hyperbolic of X over C, so we can solve for X. So that's the remaining length of the cable, 400 feet total minus this length L here as our guide. So Y square equals C square plus S square, where Y is C plus 100 at this point. So substitute, we can solve for S. So 560.38 plus 100 square equals C 560.38 square plus S square. Therefore, the length of the cable S can now be found, and it is equated to 400 minus L. So from here, we can solve for L. And L is equal to 49.75 feet. So that's it for this problem. Level 32 problem on cables. The cable of mass 1.8 kilogram per meter is attached to a rigid support at A and passes over a smooth pulley at B. If the mass M is 40 kilograms, is attached to the free end of the cable, find the two values of D for sag D for which the cable will be in equilibrium. So note that the smaller value of D represents stable equilibrium. So this is the given figure. So since it is only the weight of the cable that is given, uniform weight 1.8 kilogram per meter, we convert that to newtons per meter by multiplying 9.81. The mass M is 40 kilograms, so the tension here at B, the tension at B, which is vertical here, tangent to B there, or the horizontal anywhere on the pulley because the pulley is frictionless, is equal to 40 times G, M. And it is also equal to the uniform weight of cable times Y. And Y is C plus D. So let's superimpose the origin, the X and the Y axis so that this is clear C. So tension equals W times Y, and the tension is capital M40 times 9.81 equals W, which is 1.8 times 9.81 times Y, or YB. So Y is 200 over 9 meters, and this is equated to C cosine hyperbolic of X over C, so that we can solve for C. So, and X is half of 18, so it is 9. So 200 over 9 equals C cosine hyperbolic of 9 over C. Using the calculator, C is 3.584 meters, and the other value is C is 20.8182 meters. So Y, which is 200 over 9, is equated to C plus D, so that we can solve for the sag, the two values of the sag, because there are two values of C. So Y equals C plus D. 200 over 9 equals 3.584 plus D. So the first value of D is 18.64, the higher value. And for the smaller value, 200 over 9 is 20.182 plus the sag D. So the other answer is 2.04. So this lower value, as stated here, represents the stable equilibrium condition. Now, in your part, since the sag, especially for this smaller value here, try to treat this as parabolic cable, but only for this lower value here. Level 33, one end of cable AB is fixed, whereas the other end passes over a smooth pulley at B. If the mass of the cable is 1.5 kilogram per meter and the sag is D equals 1.8 meters, determine the mass M that is attached to the free end of the cable using the parabolic approximation, and B using the accurate analysis, which is treated catenary cable. So this should be a catenary cable, but because the given sag is 1.8 divided by 18, so that's 10%, it satisfies with my established criterion that we can approximate this as parabolic cable when sag to span ratio is less than equal to 10%, in this case 0.1, equal to 0.1. So the tension at B is equal to capital M times G, and from there we can solve for the, because the sag is given, we can solve for the sag. The tension at B is square root of the horizontal component of tension, which is denoted by big H square plus WX square. W is given 1.5, so times 9.21. Then X is half of 9. H, because this is symmetric by parabolic approximation, capital H is WL square over 8D. And D is given, so everything can be computed. So tension at B is capital M times G. And that's our working equation to solve for M. So tension at B is square root of big H square plus WX square, where H is W, where W is 1.5 times 9.81, so 14.715 newtons per meter, and big H is WL square over 8D, or H times D by the general cable theorem is equal to the moment on the beam at the same point loaded with uniformly distributed load, which is WL square over 8. So big H times D equals WL square over 8. So substitute H is 14.715 times 18 square over 8 times 1.8. So H is equal to 331.09 newtons. Substitute into this equation to solve for T sub B. So T sub B is square root of 331.09 quantity square plus quantity 14.715 times 9 quantity square. 9 is half of 18, remember. So tension at B is 356.59 equated to M times G, and G is 9.81. So M can now be computed. So take note, this is by approximate uh, parabolic approximation. So M is 36.35 kilograms. So for the accurate analysis, treating this as catenary cable, so let's superimpose the X and the Y axis. So C, this is C, and this is D. Let's solve for C, which is y equals C cosine hyperbolic of X over C, and Y is C plus D, and D is given 1.8. So C plus 1.8 equals C cosine hyperbolic of 9 over C. So from there, using the calculator, C can now be computed 22.794 meters. So tension at B therefore is equal to W times Y, and Y is C plus D. So WY, tension at B is 14.715 times quantity C 22.794 plus D, which is 1.8, and it is equated to mg, so we can cancel G. By the way, I mentioned 14.715, then you can then divide it by 9.21. So in this calculation, I just multiply it by G for W 1.5 kilogram per meter times G, so that we can cancel G. So solving for M, M is 36.89. So this is the more accurate answer. Level 34. The chain AB weighs 73 newtons per meter. If the force in the cable at B is 3560 newtons, determine the length of the chain and the value of H. So H here is this vertical distance. So let's have the tension at A, which is down to the left, and at B 3560, which makes 45 degrees. So we can compute the horizontal component of tension and the vertical. Since this is 45 degrees, the horizontal component of tension and the vertical components will be equal. And knowing H, the horizontal component of tension here, which is the tension also horizontal component of tension at A, then from there we can solve for C, the location of the lowest point with this number here. So that is H V sub B. They are equal because this angle is 45. Sine and cosine of 45 degrees are equal. So that is H, and V sub A is downward because the tangent is up to the right. So this is the vertical component. So let's have the weight of the chain is, this is catenary cable, so uniform weight 73 newtons per meter times the length of the chain from A to B. To solve for the length of the chain from A to B, we must locate first the lowest point to solve for C. So this is SA, that extension. So, and SB is this total length. So the length of the chain is SB minus SA. So that's our working equation. Then H can be solved as the difference between YB and YA. This is YA and this is Y sub B. So H is 3560 cosine of 45 degrees. So H is 2517.3 newtons, and it is also the vertical component of tension at B because sine and cosine 45 degrees are equal. Then H is WC. So H is 2517, so call that YB. And that's his H. T sub B is WYB. So 3560 equals 73 times YB. So YB can now be found equal to 48.767 meters. To solve for YA, we need C. So from H equals WC, 2517.3 equals W times C. So C is equal to 34.484 meters. Then we can now solve for YA. YA is C cosine hyperbolic of XA over C. But before that, let's solve for X sub B so that we can solve for XA. XB is the horizontal distance from the y-axis to B. Then XA is XB minus 6 because 6 is given. So YB equals C. YB is 48.767 equals C cosine hyperbolic of XB over C. So for inverse cosine of 48.767 over 34.484, then times 34.484, then that's X sub B. X sub B is equal to 30.393 meters. Having found X sub B, we can solve for XA. This is X sub A, 30.393 minus 6. So X sub A is equal to 24.393 meters. Then, from y square equals c square plus s square. So YA is 34.484 cosine hyperbolic of XA over C. So YA can now be found 43.477 meters. So we use this formula, simpler formula for S, which is y square equals c square plus s square. You can also use S equals C sine hyperbolic X over C if you want. So for SB, so YB is 48.767 square equals C square plus SB square. So SB is equal to 34.483 meters. That's the length of this imaginary chain from this point up to B. Then let's solve for SA. YA is 43.477 square equals 34.484 square plus SA square. Then SA is equal to 26.478 meters. So finally, the length of the chain can now be found SB minus SA. So SAB is 34.483 minus 26.478. So the length of the chain from A to B is 8.006 meters. Then for H, it is YB 48.767 minus YA 43.477. So H is 5.290 meters. So if we check our answer, the straight line distance from A to B, that should be very slightly shorter than the actual length of the chain by Pythagoras theorem, square root of 6 square plus 8 square, where h is 5.290 square. And it will give us about 8 meters, which is expected to be slightly lower than this. So that's the way to check your answer. Level 35. Determine the sag to span ratio for which the maximum tension in the cable is equal to the total weight of the entire cable AB. So here is the given cable and the conditions. So this is a catenary cable again, because it is the weight of the cable it is just a cable that sags and it forms this one. So let's compute D over L. And the condition is the maximum tension, which occurs at A or B because they are equally leveled supports, is equal to the total weight of the entire cable, which is the uniform weight of the cable, times the total length of the cable, which is 2S in this case, if you denote that by S, and that's also S. So let's have the superimpose x and y axis. So this distance is c from the bottom to lowest point on the cable, and that's d. And the given condition, tension at A or B, is W times 2S. So that's S, this one, and this is also S. So T is W times Y, and it is also W times 2S. From here, Y equals 2S. Y equals YA equals YB. So Y is C cosine hyperbolic of X over C, where X is half of L, and S is C sine hyperbolic of X over C. So C cosine hyperbolic of X over C equals 2 times C sine hyperbolic of X over C. Simplifying, tangent hyperbolic of X over C equals 1/2, because we can cancel C. So X over C therefore is inverse tangent hyperbolic of 1/2. And X is 0.5 of L over C is 1/2. So from there, we can solve for C in terms of L. So 0.5 of L over C is inverse tangent hyperbolic of 1/2 is 0.5493. So C in terms of L is equal to 0.91025 of L. Having found C, then we can compute Y. So Y is 2S and Y is C plus D equals 2 times S C sine hyperbolic of 0.5 L over C. Since C is known, so 0.91025 of L plus D is 2 times 0.95025 L sine hyperbolic of 0.5 L over 0.91025 L. Cancel L, and we can evaluate this right side in terms of L. So 0.91025 L plus D equals 1.05105 of L. So D is 1.05105 L minus 0.91025 L, and it is 0.1408 of L. Therefore, the sag to span ratio D over L is 0.1408. So that's it for this problem.